Okay, so today we're going to go over from parallelograms to triangles. This is our makeup module, so please pay attention. The warm-up, same parallelograms, different bases. Number one, here are two copies of a parallelogram. Each copy has one side labeled as the base, B, excuse me, and a segment drawn for its corresponding height and labeled H. The base of the parallelogram on the left is 2.4 centimeters. Its corresponding height is 1 centimeter. Find its area in square centimeters. So if our base is, let's change that. Base is 2.4. That looks like a 9. Okay, and our height, they said, was 1 centimeter. 1 cm, 2.4 cm. What is the area? And if we remember, in order to find the area of a parallelogram, it is base times height equals area, or B times A, B times H equals A, area. If that's our base and that's our height, we're going to plug these numbers in. So 2.4 times 1 equals 2.4 centimeters squared. Don't forget the 2. Okay, so that is our answer for that. Area is 2.4 centimeters squared. Okay. Explain your thinking. I multiplied the base, which equaled, base was 2.4 centimeters, and the height, which equaled 1 centimeter, and got 2.4 centimeters squared. Here are two copies of a parallelogram. Each copy has one side labeled as the base, B, and a segment drawn for its corresponding height and labeled H. The height of the parallelogram on the right is 2 centimeters. How long is the base of that parallelogram? So if you remember, the formula for finding the area of a parallelogram is base times height equals area. Okay, so we know that. They say this one over here, if the height is 2 centimeters, well, what is the base? So let's plug that in. So we know our base is 2. 2 times H, which we don't know, is going to equal our area. Actually, we do know our area. If we look at this parallelogram and this parallelogram are the same. And if I go back, do you remember what the area was? So the area for the one on the left was 2.4 centimeters. So we do have that answer. Okay. So 2.4 and 2.4, they are equal. But now they changed up where the base is and where the height is. They were able to do that because if you notice, they made this line our base, but it had to run into a perpendicular line, such as this one. When they run into each other, they make a 90-degree angle. So again, we're going to plug in 2.4 centimeters squared for our area. And now we're just going to do some simple division. So 2 times H equals 2.4. Let's change it up. 2.4 divided by 2 equals what? Well, I know that half of 4 is 2, and I know that half of 2 is 1. So our answer is going to be 1.2 centimeters. That is going to be our base. The base is 1.2 centimeters squared. Okay, submit and explain. I knew that the area of the parallelogram on the left was 2.4 centimeters squared. The parallelogram on the right gave me the height, which was 2 centimeters. I had to do division instead because I only got the number, I only got the length, not the length. I only got the numbers for the height and the area. So 2.4 divided by 2 equals 1.2 centimeters. Next. 2 polygons are identical if they match up exactly when placed on top of one another. Draw one line to decompose each of the following polygons into 2 identical triangles. If possible, check the boxes below if it is possible to decompose into 2 identical triangles. So if I was to cut A in half, these are 2 identical triangles. Check and check. Perfect. They are the same. If I slice B in half, that triangle is the same or congruent as the top. Now with C, if I was to cut this in half, that triangle is way different from that triangle. First of all, this triangle has a 90-degree angle. I don't see any 90-degree angles in the other triangle, so C is out. Let me circle A, circle B. We look at D, I'm going to cut from corner to corner, opposite corner to opposite corner, 90-degree angle, 90-degree angle. These are a match. So that will create 2 identical triangles if I decompose that rectangle. Now for this one, for E, it's kind of tricky, but these are not identical. This triangle is not the same as that. Wait, that's an X. That one does not go together, and neither does that one. They are not a match. For this parallelogram, I'm just going to cut right there. That triangle is congruent to that triangle. That is a match. And in this parallelogram, I'm going to cut from point to point. That triangle is identical as the other one. So let's make our mark. Which shapes, again, when you decompose them and cut them in half from opposite angle to opposite angle, will create identical triangles. We said A, we said B, we said D, and E, not E, F, and G. Perfect. Next. Study the quadrilaterals that can, in fact, be decomposed into 2 identical triangles. What do you notice about them? Write a couple of observations about what these quadrilaterals have in common. So since we know that A works, I'm going to cross out C. Actually, no, I'm not. Let's keep them. We know A worked, B worked, D worked, F worked, so did G. But C and E did not. So my observations are that the shapes that can create 2 identical congruent triangles, my observations are that the shapes that can create 2 identical congruent triangles have 4 sides. they also have opposite identical angles. So if you notice, like this angle opposite from A is 90 degrees, and that angle is 90 degrees. If we had cut from here to here, that angle is obtuse, and so is the angle that's opposite. And when we cut it in half, we're able to create identical triangles. When we look at C, do you see how if I cut from here to here, we're not going to have the same. This angle is obviously super obtuse. This angle is a little obtuse. So they're not the same. For D, when you cut them in half, you have a 90-degree angle and a 90-degree angle. And if you notice for this one, especially E, that's an obtuse angle, right? But if you look at the opposite angle, opposite from it, that is acute. That's acute. And this one is obtuse. So that doesn't work. So they also have opposite identical angles, as well as identical base and height measurements. Okay, submit. Next, drag the red points to create some other types of quadrilaterals that were not seen in the previous set. Drag the green points to try to decompose them into two identical triangles. Can you do it? Come up with a general rule about what must be true if a quadrilateral can be decomposed into two identical triangles. So for this one, there we go. That is a parallelogram. I'm going to slice from opposite angle to opposite angle. Boom. For this one, let's create another parallelogram. There we go. Let's take the green, cut it in half right there. And let's make a super long rectangle. Okay. There we go. All right, come up with a general rule that must be true if quadrilateral must be decomposed. Rule number one. Rule one. Must have four sides. Rule two. Must have equal opposite sides. Must have, let's fix that. Must have two sets of opposite, no, sorry, I don't know why I keep saying that. Two sets of parallel lines. So for example, I wish I can draw on it. So when I look at this, you have to notice, for example, that this line and the opposite line, that's a set. They are parallel, right? Now, if I look at the opposite side, this line and this line, they are parallel to each other. So that's two sets. Parallel, parallel, switch it up. That line and that line are parallel to each other. So that's two sets. This line and this line are parallel and opposite from each other. And this line and this line are opposite, and they are parallel. Let's switch it up in case you can't see that color. There we go. Okay. So must have two sets of parallel lines. One set, two sets. And rule number 3. Must have opposite identical angles. Not angels. So if you notice, this angle right here is 90 degrees and the opposite is also 90 degrees. If you notice, this angle is acute and the opposite angle is identical, and it is also acute. All right, share with class. Determine whether each pair of triangles can be composed into a rectangle, a parallelogram, or both, or neither. Drag the green point to turn the triangle to the right on the right. Move each triangle by clicking and dragging the shape. Okay, so I have two identical triangles. I'm going to move this by moving the angle. And then I'm going to put that there. Okay. When I put them together, they create a rectangle. And remember, it does look like a square. A square is a special rectangle. So that's why we can say a rectangle. Parallelogram, remember, is two sets of parallel lines, and that also has parallel lines. So we're going to say both. I say both because a rectangle has four 90-degree angles and a parallelogram has two sets of parallel lines, which I see in that. Let's do one more together. So for this one, let's put these triangles together. Uh-oh. So let's try that. Does that work? Okay, let's keep moving it. Okay. Okay. So this is not a rectangle. I do not see any 90-degree angles, but it is a parallelogram. These two triangles create a parallelogram because it has two sets of parallel lines. It cannot be a rectangle because it does not have any 90-degree angles, period. So you're going to do the rest on your own. You're going to move these shapes and see what could they be. And then you're going to answer. Once you select your answer, you have to tell me why. You can't just move the triangles and pick an answer. Let's say you say neither, you have to explain why. But I noticed that this isn't neither. Again, all right, I'll do this last one. This does not create a rectangle, but it does create a parallelogram. You need to explain your thinking in order to get full credit. Don't forget to do that. Same thing for that, same thing for that. Okay, 13, same thing. You're going to do that. Synthesis. First, we tried to decompose or break apart quadrilaterals into two identical triangles. What strategy allowed us to do that? Slicing or decomposing the shape or the four-sided shape four-sided rectangle or parallelogram from opposite angles. And put a little tick mark right there, and then I'm going to go to the next one to represent the next part. Which types of quadrilaterals could always be decomposed into two identical triangles? So I'm actually going to take the question, reword it right here, but fix it. Which types of quadrilaterals? Rectangles and parallelograms are quadrilaterals that can always be decomposed into two identical triangles. You see how we did that? We just took the question and embedded it into our answer. And then, can quadrilaterals that are not parallelograms be decomposed into triangles? Yeah. Yes. Rectangles. Oh, wait, but rectangles pretty much are parallelograms. No. They have to be either a rectangle or a parallelogram, which means they have four sides and two sets of parallel lines. Remember, rectangles do have two sets of parallel lines. So I'll prove it to you. If I make this a rectangle, let's see, that's a trapezoid. Now it's a rectangle. So this rectangle, the line up here is parallel to the line below. That's one set. And the line on the left is also parallel to the line on the right. However, if you notice, the distance 1, 2, 3, 4 units on the right and 1, 2, 3, 4 units on the left is not the same as the top. 1, 2, 3, 4, 5, 6, and 6 at the bottom. 1, 2, 3, 4, 5, 6. So 6 up at the top and 11 on the 4 on the sides. So, and even if it was a square, we're still going to have 1, 2, 3, 4, 1, 2, 3, 4. This line is parallel to this line, and this line is parallel to that line. It's the same thing. So only rectangles. Remember, rectangles can be squares. Also squares. A square is a special rectangle. And parallelograms are the shapes that can be used. Not right now. Okay. Synthesis. Then we explored the relationship between triangles and quadrilaterals the other way around. We tried to compose or create quadrilaterals from pairs of identical triangles. What types of quadrilaterals were you able to compose with a pair of identical triangles? All right, let's take a bit of our question. Let's put it right here. What types of quadrilaterals? Let's change it into our answer. What was I able to make? What types of quadrilaterals? I was able to create rectangles and parallelograms. So actually, I didn't need all that. Oh, there we go. I was able to create, or what's another word for create? Compose. I was able to create / compose rectangles and parallelograms with a pair of identical triangles. Okay. The next one, does it matter what type of triangles was used? No. It depends. It depends because only some triangle pairs will only make a parallelogram. Some will not make a rectangle. Okay. Next part, was there a particular side along which two triangles must be joined to form a parallelogram? Along their base. So it only depends on the sides you match up, that the lengths match up. So for example, if we're matching this side to this side, let's see what happens. It's got to be the same side. That doesn't work. Let's rotate it around. There we go. Maybe this side. There we go. Yes, so they have to match up based on the same length. So this side on this triangle, the first one, let's say it's 5. This one also has to be 5 on this side, so they have to match up. Match up. So if one side of the triangle measures 5 inches, then you have to match it up with the other triangle that is also measuring 5 inches. There we go. Boom, done. Here are some quadrilaterals. Circle all the quadrilaterals that you think can be decomposed into 2 identical triangles using only one line. So again, this is where you're using this line and you're trying to figure out where should it go. So I'm going to let you do that. What characteristics do quadrilaterals that you circled have in common? So let's turn the question around. I'm going to help you out. Not what, the characteristics that the characteristics of the quadrilaterals that I circled have these things in common. There you go, ... I would like you to answer this. So this is a part that tells me that you were paying attention and that you know what to do. So please answer that. Again, you can always pause the video to answer. Number 17, here is a right triangle. Show or briefly describe how 2 copies of it can be composed into a parallelogram. 2 copies of it. Let's see. Undo. So I think what you're going to do with the drawing tool or this tool is you're going to be creating another triangle. And then you're going to show me how it can be composed into a parallelogram. So create a parallelogram. I'm going to write that. Create an identical triangle and put them together. You don't need to write this. I'm just writing it for you. And put them together. Okay, to create a parallelogram. Okay, next. Reflection. Respond to at least one of the following prompts. What did you learn today? What are you still struggling to understand? What is one comment, concern, or question that you still have? So this is your time to pick one of these. You could say, what did you learn? Tell me about it. Or you could tell me what you're still struggling, or what's a comment or concern you have. Thank you, and I hope that this was clear for you to follow and that you are able to complete this whole module to get full credit. Thank you.